Okay, so now we're going to look at the t-distribution. So find the critical value TC for a confidence level of 95% and n equals 16. So remember the important things here now. If we're going to be looking, we need to know the confidence level, and we need to know the sample size because that's going to affect our degrees of freedom. So remember that C of 0.95, 95% confidence level, would leave 5% in the tails, or in other words, 0.05 in the combine of both tails. So that's what we're going to use. And n equals 16, remember the degrees of freedom is n minus 1, so we would get 15. So these are the two values that we can look up, use to look up. So let's get back. So we're going to use the t distribution, and we're going to go on the inverse because we're going to be giving a probability. And we're using the two-tail version because we're using the total area in both tails. So 0.05. And then we had 15 degrees of freedom, and that gives us 2.131. And there's your 2.131. All right, find the value of E, the margin of error, for the confidence level, N and S. Okay, so the difference here is just that now we're going to do the margin of error as the critical t value times S over, over the square root of n. So we have to find our critical t value here. But again, that's going to be based off of both the confidence level and the sample size. So we have 90% confidence level, but that leaves us 0.10 in the tails. And we have degrees of freedom as 1 less than the sample size, so 9. So I have to go look that up. So t, I forgot the equals t dot inverse two tails, 0.10 and 9, 1.833. So we get 1.833 times 3.2 over the square root of 10. And realize we are using n in there, not n minus 1, so that is n down there. And that's going to give us about 1.85. There we go. All right, confidence interval using this information. All right, again, first it starts with getting the margin of error. All right, for 95%, that's going to leave us 0.05, 5% in the tails. And our n is 16, so our degrees of freedom is 15. Look up a value. We said 5% left over, 0.05, and we said 15 degrees of freedom, 2.131. Times S is 31 over square root of 16, which gives me about 16.5. So then I'm going to take x bar, subtract e from that, and add e to that. So where's our X bar? Was 645 minus 16.5 and 645 plus 16.5. That is going to give me 628.5, and here we're going to get 661.5. There's your answer. All right. In a random sample of 28 families, the average weekly food expense was $95.6 and standard deviation of 22.5. Normal, T, or neither? Okay, so remember, one thing that we need is we either need the original distribution to be normally shaped, which here it says it is, or we need the sample size of at least 30. We didn't have that, but we do have the normal size shape of the original distribution. Then the question is, do we have the standard deviation of the population? Now here it said in the random sample, we had a certain mean and standard deviation. So what they gave there was S. We do not have sigma, which means we would be using the T distribution. All right, if we look at this one, let's see what we have here. For a sample of 20 IQ scores, the mean was 105.8. Standard deviation sigma, they're giving us sigma, is 15. Okay. Assume the IQ scores are normally distributed. That means we can use one of these distributions. Now, because they gave sigma, I can use the normal. All right, construct a 95% confidence interval for the population mean. Population has a normal distribution. Sample of 25, n is 25, has a mean and a standard deviation. All right, so that's coming from the sample. So they're telling me X bar is 81.5, and they're telling me S, because it came from the sample, 10.2. So this all means I'm going to have to use the T distribution. Okay. So I can set it up as usual. Oh, they did say 95% confidence level, which means there's going to be 5% in the tails, or 0.05. That's going to matter when I go get my critical T value. So again, first I'll do the margin of error. All right, so my critical T value, I have to do it based on, so again, my degrees of freedom, because my sample size is 25, is one less, 24. And so I'm going to look up the inverse, two-tailed. What do we say? 90.05 left over, and 24. 2.064, we'll say. Okay, so we get 2.064 times S 10.2 over the square root of 25. Okay, and this comes out to be about 4.21. So for the confidence interval, I just take X bar and I subtract E and add it. So X bar was 81.5, take away 4.21, and then do 81.5 and add 4.21. And we should get 77.29 and 85.71 right there. That's our interval. Oops. Just trying to clean that up. There we go. Okay, so that's all of it.